Our 10th problem is a very beautiful and unique combination of permutation, combination and binomial theorem chapter. We are given that a person who is sitting in an examination needs to score 2m marks. There are 4 papers having a maximum of m marks each. We need to find the total number of ways in which this person can score 2m marks. Now from the first paper, let's say paper 1, a student can score 0 marks, 1 mark, 2 mark or m marks. Similarly from the paper 2, he can score 0 till m marks. From paper 3, again 0 till m, and in paper 4, again 0 to m, and he needs to score a maximum of 2m marks. So there is a very beautiful method of binomial theorem over here. In other words, we need the person to score 2m marks. In other words, we need to find the coefficient of x bar 2m from x bar 0 plus x bar 1 plus x bar 2 up till x bar n into x bar 0 plus x bar 1 up till x bar m, and this is written 4 times since there are 4 papers involved. This represents that the person can either score 0 marks, 1 mark, 2 mark or m marks. There are m plus 1 cases, and hence we have written this in the form of x bar 0 plus x bar 1 up till x bar m, and the same thing for paper 2, paper 3 and paper 4, and we need to find the coefficient of x bar 2m from this entire product, because the person needs to score a total of 2m marks. Now this is a GP return having the first term 1 and having number of terms to be equal to m plus 1. So this is equal to the coefficient of x bar 2m from 1 minus x bar m plus m, or rather m plus 1 upon 1 minus x whole power 4, or this is equal to 1 minus x bar m plus 1 power 4 into 1 minus x bar minus 4. Now we know that the expansion of 1 plus x bar n is 1 plus n plus nc1 x plus nc2 x square up till nc n x bar n. So this we can write it as, or rather we will write it again over here. This expansion is equal to 1 minus 4 into x bar m plus 1 plus 6 into x bar 2m plus 2 minus 4 into x bar 3m plus 3 plus x bar 4m plus 4 multiplied by the expansion of this, and we know that a general term for this expansion is r plus 1 into r plus 2 into r plus 3 upon 3 factorial x bar r. So over here we need to find the coefficient of x bar 2m from the product of this bracket into this bracket. Now what we have is, this is a useless term for us because we need to find the coefficient of x bar 2m, and this term is already greater than x bar 2m. So this is useless for us, this is again useless for us, and this is again useless for us. So the only terms which are beneficial for us are 1 and x bar m plus 1, since we need to find the coefficient of x bar 2m, and this is already written x bar 2m into x square. So these 3 are useless terms for us. We already have x bar 0 over here, so we require x bar 2m from this bracket only. So we have 1 into x bar 2m, so we put r equals to 2m, so this becomes 2m plus 1 into 2m plus 2 into 2m plus 3 upon 3 factorial, and over here we already have m plus 1. In order to make the entire power of x to be equal to 2m, we require the coefficient of x bar m minus 1 from this bracket, so that when this gets multiplied with this is m plus 1. If this is m minus 1, the entire thing will become 2m. So we require r to be equal to m minus 1 over here, minus 4 times, putting r equals m minus 1, this becomes m into m plus 1 into m plus 2 upon 3 factorial. We can simplify this thing. This is 6, so we can take a 6 common. We can also take a 2 common. So this becomes 2 into 1 by 6, which is 1 by 3. This m plus 1 common. So this becomes m plus 1 upon 3 into 2m plus 1 into 2m plus 3, which is 4m square plus 8m plus 3 minus, as we took m plus 1 common, we obtained, since 2 was taken to be common from both the things, we have 2 left over here, into m plus 2. This is m square plus 2m multiplied by 2, that is 2m square plus 4m. This is equal to m plus 1 upon 3 into 2m square plus 4m plus 3, and hence our final answer comes out to be equal to m plus 1 upon 3 into 2m square plus 4m plus 3. And hence in this problem we saw that this question was a bit tricky problem. It was not solved by the usual methods which we apply in the permutation combination problems. This was a very unique combination and a very important problem as far as the combination of binomial theorem and the chapter permutation combination is related. This problem was solved using the concepts of binomial theorem, and hence we obtained the final answer for the number of ways in which a person can select or get 2m marks in an examination is m plus 1 upon 3 into 2m square plus 4m plus 3, and this is our final answer.